Welcome back to Module 3. In this module, we will explore the fundamental concepts of data sets, including what they are, why they are essential, and how to work with them efficiently. We will start with the first question: what is in a data set? And then delve into exploratory data analysis. A data set contains a collection of data records, which can include variables, values, and observations. The contents of a data set exhibit significant diversity, contingent upon the nature of the data being amassed and the objectives of the data collection process. Typical examples encompass demographic information, financial information, medical records, customer behavior data, and scientific measurements. The structure and format of a data set can also vary, with common formats including spreadsheets, databases, and text files. Any data set will include at least the following three characteristics displayed on the screen. The first one, variables, are the characteristics or attributes of the data being recorded. For example, in a data set of customer information, variables might include name, age, address, and purchase history. Next are values. They are the specific data points recorded for each variable. For example, in the case of the customer name variable, the values might be Donald Duck or Mickey Mouse. Lastly, observations. This refers to a single record of data within a data set. For example, in a data set of customer information, each customer would represent a single observation, with the values for each of their attributes, like variables, recorded for that observation. To summarize, variables define what is being measured. Values represent the specific measurements taken, and observations represent a set of values for a given set of variables. Exploratory data analysis, EDA, is a crucial step in data literacy, where the aim is to understand the characteristics of a given data set by using various statistical and graphical techniques. EDA is typically the first step taken after acquiring data. It is important for uncovering patterns, relationships, and potential issues within the data that could impact subsequent analysis and decision-making. Exploratory data analysis, or EDA, is not just a method but a fundamental shift in how we approach data, introduced by John Tukey, a pioneering American statistician, in the mid-20th century. Tukey's work during the 1960s and 1970s marked a revolution in data analysis, pushing the boundaries beyond traditional statistical techniques and laying the groundwork for what we now consider modern data analysis. Tukey's major contribution, encapsulated in his seminal work Exploratory Data Analysis, was to advocate for a more intuitive approach to understanding data. He emphasized the importance of graphical and statistical methods not just as tools for analysis but as means to uncover the deeper stories data tells us about the underlying phenomena. This approach seeks to reveal patterns, relationships, and anomalies that might not be immediately apparent but are crucial for making informed decisions and hypotheses. What makes Tukey's ideas so revolutionary, and why they have left such an indelible mark on the field, is their applicability across various disciplines. From healthcare to finance, EDA has become a cornerstone of data analysis, guiding both the seasoned data scientist and the academic researcher. In today's data-driven world, EDA stands as a critical initial step in the data science process. It's the stage where we begin to understand the contours of our data, ask preliminary questions, and prepare for deeper analysis. The widespread adoption of EDA techniques reflects their importance in not just understanding what our data can tell us, but in unlocking the inherent value within it to derive actionable insights. In essence, Tukey's legacy through EDA is a testament to the power of exploring data with curiosity and openness, allowing us to make more informed decisions and uncover the insights hidden within the numbers. As we dive into the realm of exploratory data analysis, or EDA, it's crucial to grasp its dual objectives that guide our journey through data analysis. The main objective of EDA is to familiarize oneself with the data and to gain insights into the underlying patterns and relationships. In this module, we will discuss some of the main EDA statistical techniques that will give you a better understanding of what data you are actually looking at. The secondary objective of EDA is to summarize a data set, so you have the ability to understand better the data you are looking at. Data summarization is a process of reducing the amount of data by presenting the key features of a data set in a concise and meaningful way. The goal of data summarization is to provide a quick overview of the data that helps to identify patterns, trends, and relationships within the data. This can help to make the data easier to understand and to inform subsequent data analysis. We will discuss two main methods for summarizing data in this course. The first one is descriptive statistics. Descriptive statistics are numerical values that describe the central tendency and dispersion of the data. Examples of descriptive statistics include the mean, median, mode, standard deviation, and quartiles. Descriptive statistics provide a quick and easy way to summarize large amounts of data, and they are often used to identify patterns and trends in the data. The second one is frequency distributions. A frequency distribution is a table that shows the number of occurrences of each unique value in a data set. Frequency distributions are useful for summarizing categorical or nominal data and for understanding the distribution of the data. Exploratory data analysis is a fundamental first step in understanding the data you are looking at. As a best practice, it is recommended to execute the various EDA techniques discussed in this section on every data set you ever consider. In our next module, we will delve into each of these methods in detail.